Hi, I'm doing a video key for geometry exit ticket 16.2, and here are a couple of proofs you need to deal with. So remember that a scaling triangle has all different side lengths. So we've got EG equals FH. Okay, we know that, which we can now assume that FG is smaller than FH, and therefore it's smaller than EG. We also know that EF is smaller than EG. Okay, so we've got, EF is larger than EG. That's what I mean to say. So after we take care of the givens, okay, and let's lay them out. We know that EF is larger than EG. We know that EG is equal to FH, but since EG is equal to FH, we can assume from diagram that FG is less than FH, assumed from diagram. And then because of that, we can now say that FG is less than EG by transitive property, actually by substitution, I should say. Okay, and so now that we know, oops, let me fix that, substitution. Okay, so since FG is less than EG and EF is greater than EG, we can say EF is greater than EG, which is greater than FG. So no two sides are the same length. Triangle EFG is scaling by definition of scaling. Okay, now let's take a look at this one. We've got an isosceles triangle proof. So we need to prove that KPM is isosceles. To prove that KPM is isosceles, we need to prove that this side and this side, well, we need to prove two sides are congruent. These are the most likely sides. Okay, what would be useful would be then we've got these overlapping triangles, and we could prove that either these two triangles are congruent or this triangle and this triangle are congruent, then I think we could do this. I think the easiest thing to do is prove the two larger overlapping triangles are congruent, because we have that angle 1 is congruent to angle 3, angle 2 is congruent to angle 4, and then we also have JP and OP. We'll need those later. We can talk about, okay, after the givens, now we can say, let's say KM is congruent to itself, because that's a side that both overlapping triangles share. KM is congruent to KM by reflexive property. Okay. Let's try that again. Okay, now we also know, we can also prove that angle JKM is congruent to angle OMK. And we can do that by addition. Angle JKM is congruent to angle OMK by addition of congruent segments. Angles, actually. Okay, and because of that, now we can start organizing some congruent stuff. So we can prove that we know these two angles are congruent because of given. We know that these angles are congruent by addition. And we know that this side is congruent to itself. So now we have angle, side, angle, and angle, side, angle that will prove that these two overlapping triangles are congruent. So now we can say triangle JKM is congruent to triangle OMK, and we can do that by angle, side, angle. Okay, and now we can add that JK and OM are congruent. actually, we can say that JM and OK, that's what we need because we need to prove that PM and PK are congruent. So JM and OK are congruent. JM is congruent to OK by kappa, kata, ka. Corresponding parts of congruent triangles are congruent. And now, since those sides are congruent, we can now prove that PM and PK are congruent because JP and OP. So at this point, we would bring in JP is congruent to PO, and that's given. And then we could say that PM, it could have been MP, that's fine. PM is congruent to PK by subtraction, okay? Because we know that JM and OK are congruent and JP and OP are congruent. So if we subtract JP from JM, we get a congruent difference to KP because we can subtract OP, our PO, from OK. Okay, and once we know that, we can say triangle KPM is isosceles because sides PM and PK are congruent. And that defines an isosceles triangle.